Hello everyone! Today we will learn how to build an anemometer, but before saying how it's done, we will tell you what it is and some necessary data. The anemometer, also known as anemograph, is a meteorological instrument whose task is to measure the average velocity of gaseous fluids, working as a tool for the development of multiple areas and activities. In more basic terms, it is a device used to measure the wind, but it is not the only thing that can be measured, since its ability to calculate the speed covers all gaseous fluids. Now that we know the main function of the anemometer, how can we use it? As the anemometer measures the speed of the wind, its use is very useful for an endless number of tasks, such as fishing, the flight of the aircraft, from the largest planes and helicopters to the smallest drones, the meteorology, the agriculture, among others. How does an anemometer work? The most widely used type of anemometer could be said to be the cow type, which calculates the wind speed by counting the number of turns that are recorded, expressing them in meters per second. This type of anemometer is what we'll do next since it's very easy to make and we can use recyclable materials.
Materials: 512 ounce glasses, two 24 cm square, a plastic plate, a strack, silicone gum, rule, cutter, accessor, pints in the color of your choice, a tablet. For circuits: two breadboards, two 9-volt batteries, a transistor, a variance resistor, a LED and include sensor, cables to connect to breadboard, a motor. Fish speed: mark 5 points 5 centimeters from the top of the glass with a pencil. We must do this speed with 4 glasses. Then execute following the line that we mark with the help of a cutter. Second step: mark 2 centimeters from the bottom of the glass. We are helped to make 2 marks so that they are opposite, and then we must make a hole in the marks. It is recommended that you do it with the square so that the hole is the necessary size. Third speed: mark 0.5 on the straight and make a hole. Then in the opposite position, make another value. That hole as shown dimensions or square will pass through here. Fourth speed: cross the glasses with the square I indicate in the video. They must be around in such a way the button on the glass in the same direction.
Fifth step: take another glass and make a hole in the bottom part of the glass. The straw will pass through here, so make sure it is indicated size. In the bottom part of the glass you must make a cut as indicated in the video. Here you will see the game. Step 6: we are going to glue a spool in the center of our plastic plate. Later we will glue the glass on top of the spool as shown in the video. Finally, the straw is placed inside the hole of the glass and it must also enter the spool, the straw. Our anemometer is already built. You can paint it to make it look more beautiful and presentable. At the end of the video, we will show you the result. This prototype is already functional. However, we can add adjustments such as a motor and a sensor. If you want something more elaborate, follow the next steps. For our first circuit, which is where we will make the game work, we need the aforementioned materials on the screen. The soldering iron is not necessary since using a breadboard, we will not solder anything. The way in which you will connect the components is seen on the screen. Accommodate each of the connection cables as indicated in the mesh. It will have to work in such a way that the variance resistor controls the speed of the motor. Once the motor circuit is built, it is time to add it to the anemometer. The straw will have to be glued to the motor as seen in the video, but first we glue the motor to the plate in the center, then the glass, and finally we introduce the straw and it sticks to the motor.
The second circuit is to add an inductive sensor. This type of sensor will help us to record the number of turns that our anemometer makes. Since the circuit will turn off a LED bulb every time the sensor touches the metal that will stick to the bottom part under one of the glasses. The circuit is connected as shown in the video. The sensor has three outputs. The black cable is a positive charge and will power the LED light. The blue cable is a negative charge and must be connected both to the battery on its negative side and to the LED focus in its negative part. Finally, the brown cable is positive, and this is connected to the positive part of the battery. Then we are going to add an additional glass similar to the one we have in the center. In this, instead of putting a straw in the middle, we will add a piece of hose to place the sensor as seen in the video. We glue it next to the other glass. Now let's forget to make a small cut at the bottom of the glass since the sensor cable exits through the space. And now we have an anemometer with an integrated motor and sensor. How does the anemometer we built work? We will make it rotate for a certain time. The following data will be recorded: the number of complete turns it gave, that is, the number of times the sensor turned off, the time it was spinning, the perimeter of the anemometer, that is the circle formed by our glasses. Having this data, the only thing left is to calculate the speed. The first thing we must do is multiply the number of turns by the perimeter of the anemometer and divide the result by the time in minutes. And now we have an average speed. We are done. Science and technology are very fun. Our team invites you to explore your curious part more and create your own anemometer and other projects to develop your creativity and scientific part.